Hello friends, today we are discussing the protection and privilege levels part 2. Subject is the microprocessor. The overview of the 386DX protection. A 386DX has a 4 levels of the protections, which isolates and protects the user program from each other and the operating systems. So this 4 level of the protections isolates and protects the user program from each other and operating systems. It uses a segment level protections, and second is a page level protection mechanism. There are the 2 levels of the protection mechanisms are here, the segment level protection and a page level protection mechanism. Before memory cycle, each memory reference is checked by the hardware to verify that it satisfies the protection criteria. So while proceeding for the protection, a memory cycle is checked. Each memory reference is checked by the hardware to satisfy the protection criteria. A segment level protection has a 5 aspects. It is a type checking segment level protections, a limit checking segment level protections, restrictions of addressable domains, restrictions of the procedure entry points, and restrictions of the instruction set. In the type checking, it will check whether the different types of the systems are available, whether it is supported for it or not. In the limit checking, it checks the limit for the system and the addressable domains. So which domains are addressable, it will restrict that domains. And procedure entry points, it will restrict the procedure at a certain points for a protection level, and for a restriction protection level at the instruction set, it restricts some of the instruction sets. Segment level type checking. A type field of the descriptor specifies the type of the descriptors, whether the system or a non-system descriptor. A type in the type checking, it will check a type of the field of a descriptor which is specified. Second is intended uses of the segment. Example, if a segment is ready only for a segment, then its access is limited to only reading purpose. That means in a intended usage of the segment means for the specific purpose the segment is used. If a segment is read only, then the access is limited only to a reading purpose. It cannot allow for a writing purpose. That means for a specific usage the segments are used, which is goes onto the type checking purpose. A limit checking to prevent a program from addressing outside the segment. The limit checking will prevent a program from addressing outside the segment. It interprets the limit field depending on setting of a granularity bit, which specifies whether a limit value count bits a 1 byte or a 4 byte. Means whenever the limit value goes beyond all these things, the granularity bit will check and it interprets the limit field depending on the setting of the granularity. The 80386DX causes the general protection exception when the program attempts to access the memory byte at an address greater than the limit, access the memory word at an address greater than equals to the limit, address the memory data word at an address greater than equals to the limit -2. So 386DX causes the general purpose protection exceptions when the program is attempting following conditions: when address is greater than limit, when the address is greater than equals to the limit, or address is greater than equals to the limit -2. A privilege level protections are numbered 0 to 3, means a PL0, PL1, PL2, PL3. Okay, these are the privilege levels. Level 0 is the most privileged or a trusted level. So level 0 is a most privileged. That means we can say it is a trusted one level. A privilege levels are shown in a figure. A kernel, which is the most privileged level, having a PL0, a system services having a privilege level 1, whereas OS extensions having a privilege level 2, whereas the privilege level 3 is for the application. So the applications which are running on operating systems are goes under the privilege levels 3. These are the privilege levels shown in a figure. Rule for the privileges. Intel 8036 controls access to both data and procedure according to the following rules. A data segment with a privilege level P can be accessed only by the code execution at a privilege level, at least as a privilege P. Some of the examples are application programs are prevented from reading or changing OS tables. A 386DS control access to the both data and a procedure according to the following rules. Data segment with a privilege level P can be accessed only by the code executing at a privilege level, at least as a privilege P. The second rule for the privilege is a code segment with a privilege level P can only be called by the task execution at the same or a result privilege level than a P. So if we have the privilege level P, the code segment with a privilege level P can only be called by the task execution at the same or a lesser privilege level. Means if a level P is there, so it will be executed by the same level or a less than lesser privilege level. A privilege levels are three different types of the privilege levels entering into the privilege level checks. Okay, there are three different types of the privilege levels which are entering into the privilege level checks: current privilege level, descriptor privilege level, and a requester privilege level. A current privilege level is stored in a selector of a currently executing CS register code segment register. It represents the privilege level, that is a PL, of the currently executing task. It is also a privilege level in a descriptor of the code segment. It is also designed as a task privilege level. It represents a privilege level of the currently executing task. CPL is stored in a selector of the currently executing CS registers. Thank you friends for watching the video.